In the last video, we learned how data can move from one node to another, with each node performing its task and enriching the overall result. But what if your workflow needs to take different paths depending on certain conditions? That's where things start to get interesting. Because in real world AI systems, not every query or task follows a single linear route. Sometimes your graph needs to choose where to go next, and LangGraph allows that using conditional edges. So in today's video, we're going to see how to introduce choice making inside your graph, how it can intelligently choose between multiple nodes based on logic you define. First of all, we'll write the code and then I'll explain you the code here. So let me create a new file. 3.conditional graph.ipynb. I'll have some imports. First of all, from typing, I'm going to import typedict. Then from LangGraph.graph, I'll import state graph, start and end. Let me run this and then select the default interpreter. After that, we're going to write our agent state. So agent state is going to be of type dict, and I'll have number 1, which will be an integer, number 2, which will also be an integer, operation, which will be a float, string, and then I'll have a result, which will also be an integer. Okay, so this will be our agent state here. Let me run this too. Now I'm going to create few nodes here. First of all, the first node will be adder. It will contain state, agent state, and it will also result or return an agent state here. Now here what I'm going to do is I'm going to write a docstring. So this node adds 2 numbers. After this, I'm going to update my final number, or I can sorry, it's not final number, it is result. So state result equals to state number 1 plus state number 2, and then I'm going to return a state here. Okay, then I'm going to define another node here, which is called subtract, and state, agent state. The node will basically subtract 2 numbers, and then what I'm doing here is doing number 1 minus number 2 and then returning the state. Now I will define a router node here which chooses where should I go next. So decide next node. It will also contain an agent state. It will be of type agent state, and then it is simply going to return a string here. So this node will decide or will select the next node of the graph. Now I'm going to check one state called operation here. So if state operation double equals to add, then what I'm going to do is I'm going to return add operation, and then else if state operation is subtract, then I will return subtract op. Okay, so this will be my router node here. So let me run this. Then after this, I'm going to create my final graph. My final graph will be based on state graph, and then it will contain this agent state object. So agent state class. Let me add nodes here. So the first node will be add underscore node, and then and then the function for this node is adder. Second node is subtract node, and then the function for that is subtract. Then I'm also going to add a third node here. So graph.add underscore node. The third node will be named router. And then what I'm going to do here is I'm going to pass the state as it is here. So it will also be called a pass through function. So whatever we get will just be passed through that router stage here. So now I'm going to go and add edges. So first edge is going to be start, and then it will go to router. Then I'm going to add conditional edge here. So add conditional edge. What will this be based on? So this will be based on the router node, and then what will happen here is its function is this one, decide next node. So the function is here, and then the two options from this node is one is the add op, which will take us to add underscore node, and then the other is the subtract op, which will take us to subtract node. So basically we're referring to add op and subtract op from this particular node here, and then if we get add up, we'll go to add node, which means our adder function, and then if we get subtract up, we'll go to our subtract node, which is our subtract function. Okay, and then what we also need to do is, since both of these add and subtract will show the result and then go to the end of the graph, so what we need to do is we need to add two different edges here, from add to end and then subtract to end. Now since this is done, I'm going to compile my graph. Let me compile my graph, and then if I print out my graph here, we'll see that first of all we'll start from here, then we go to the router node. The router node fixes where we should go next based on the agent state called operation here. If we get plus, then we go to add node. If we get minus, we go to subtract node. From either of these add or subtract node, we go to the end here. So this is how we can introduce conditional graphs in our LangChain. Now I'm going to declare my input state here. So input state is going to be the number one will be 10. Let's say the number one is going to be 10. Okay, I'll keep it 10. Number two is going to be 4. I don't need this result here. The result will be operated on its own, and then basically operation is minus. Now if I invoke my boat using input state, and then if I print my final response, then I can see that the result is set, and then since the operation is subtract, so the result is 6. If I change this operation from plus, now the result goes to 14. So either of these two nodes are chosen based on the operation state present in our agent state here. Okay, to summarize now, we start with an agent state that carries our data, two numbers, the operation we want to do, and either addition or subtraction. Next, we define two nodes, one that adds, one that subtracts. But the real magic is inside this router function here that we have. So this function acts like our choice maker. It inspects the current state and then returns which node the graph should go next. So if the operation is positive, then we go to add node. If the operation is negative, then we go to the subtract node. So LangGraph then uses these conditional edges to make it run. So these edges dynamically connect the flow at runtime based on the conditions, based on the condition functions output. So instead of a single linear chain, what we have here is it is a conditional chain, and it behaves like an intelligent agent tree, so capable of branching out and adapting to the data it receives. So this concept, conditional routing, is at the heart of making agentic system flexible. So in the upcoming videos, we'll take this concept further, including memory as well as message passing inside LangGraph, so your agents can remember and react contextually. And that is where LangGraph truly starts to feel alive. So that is all for this video. If you don't understand anything, do comment down below and I'll try to help you out. And then if you like our content, please give a like and do subscribe to stay updated on our latest content. I'll see you in the next video again.